Alright, our last step in modeling and solving equations here, and we're using distribution that distributive property that we introduced the other day. So remember, if you're seeing something like this, you're thinking about two groups of 3, or you're thinking about 2 times 3. So in total, what we have there is we have 6. Now that distributive property tells us that if we have two groups of x plus 1, we have 2 x's and we have 2 1's. So I like to show that like this. There's our 2 x's in red. Sorry about that, guys. So 2 times x, we have 2x. And then in blue, I'm putting my palm on the screen here and it's shifting. In blue, we're doing 2 times the 1. That's this step. We have 2 1's. So we have 2. And that's our distribution step in the middle, is that 2x plus 1 can be written as 2x plus 2. So if we practice that a few times here, I like to show this every time. We have 4 a's, and we have minus the 4 times 5 piece, right? 4a minus 20. Here we have a negative 2 in front. We have negative 2 groups, and we're going to distribute that like this. So let's maybe write out both. We have negative 2 groups of 3x, and then we're and I'm going to say we also have negative 2 times negative 1. Yeah, you might think of this differently, but we're going to make sure your signs end up the same way. So we have negative 6x's plus 2. Now if you said we were going to take away 2 times 1, if you said we were going to take away 2 times negative 1, you'd be taking away negative 2. So either way, it's going to work out that we have negative 6x plus 2. If you're taking away negative 2, that's the same as adding 2. So watch the sign on that one. Last one here, our coefficient, the number in front, the number of groups is 6. So we have 6 4's, which is 24. And then we're taking away 6 times g, so we're taking away 6g. Okay, that's one way to show the distribution or think about the distribution. Notice we didn't solve any of those, it just said simplify, so we just rewrote them as kind of without the brackets. That's the simplification step, is to rewrite it without the brackets, not to solve it. In this case, another way to simplify again is to think about that model. So here we're showing that we have 3 groups of this. This is our x piece, and there's a 1. So so we could show the 3 groups of 1 like this. Here's 3 1's. So this is kind of the answer, right? We have sort of the left times the right. This is our answer. Kind of creating like an area model. We also have 3 groups of this piece, 3 x's. So it's going to look like this. There's an x, here's an x, and here's an x. Now it just says simplify, so that would work. But notice we have 3 plus 3 x's. That was 3, that was 1 plus x along the side. So we have 3 here, and we have 3 x's here. Whoops, it's kind of an ugly 3, but you get it. Over here we have 2 groups, and now all the stuff is in the group is that we have 2 x's in the group, and then we have a negative 1 in the group. So we'll first just do this piece. 2 x's is going to look like this. There's an x, there's another x. Here's the second group of x's. There's one of them, there's the other one. So 2 times the 2x gives us the 4x piece. Then maybe we'll do this separately. 2 times the negative 1 gives us 2 negative 1's. So now our answer is that we have 4x minus 2. Alright, that's what the diagrams would look like. And again, you're just showing multiplication. It's like an area model. It's like you're finding the area of the rectangle. You've got the length and the width. You've got the top and the bottom. You're completing the inside. You can use that thinking later on with binomials and trinomials, like solving polynomials. So it's good to get your head around that model too, you guys. So take a minute, write it out, show the steps, make sure you know where the 3 comes from, where the x plus 1 comes from, and how we get 3 plus 3x, right? There's our 3 from the top, there's our 3x from the bottom. And think through the other one as well. We'll get into a real life example here now. We'll look at a flower garden, and maybe you're at the hardware store, maybe you are remembering the area of your garden, but you're trying to figure out the area of that shed. So here's how you can kind of work through that or use that in your calculation here. Sorry, trying to figure out the length of the shed. It says the flower garden's in the shape of a rectangle. You see it there. The length of the garden is 2 meters longer than the shed. So there's your shed, and there's that extra 2 meters. The width of the garden is 4 meters. If the area is 20 meters, what is the length of the shed? So now we're solving for the length of the shed. First up, if you take a look at this, here's kind of that same picture of that garden. Now we just took like the shed length and we times it by 4. So here we have 4 times s, and then we took that extra 2 meters and we times it by 4. So this is like 4 times the 2 meters equals 8 square meters there, right? We also know that in total that equals 20 square meters. So we've got 4s plus 8 equals 20 meters squared. If we wanted to solve based on that, we could just take away the 8 from both sides, right? Get rid of this area, pull it out of here, so we've got nothing left there, and we've got 12 square meters left. So our 4s, that section in front of the shed, it's 4 meters wide and it's s meters long, is equal to 12 meters squared. So if we divide by 4, we know that the s must be 3 meters. Right? We know that our shed must be 3 meters long. Now it makes sense. This is a total of 5 meters on this side, and this is 4 meters here. So now the area is equal to length times width, right? So 5 times 4 gives us our area of 20 meters squared. So it all checks out. Our math is good. I'm going to show you one other way to write this, one other way to represent this. We could represent this as 4 times s plus 2. And we could say that that's equal to 20 meters squared. And now that might get you kind of thinking back to what we did the end of last week, and you'll see there's 2 different ways to solve that. We'll go over those 2 ways in the second one, but I just wanted to show you that this is another representation. We could write it like this, or we could write it like this. Either one kind of describes what we're starting with. Notice here that if we have 4 s's, there's our 4s piece. If we have 4 2's, there's our 8 piece. So 4 times 2 gives us the 8. 4 times the s gives us the 4s. And that, again, that's the distribution. It's these little kind of green and red lines that I'm drawing on top. I'm trying to show that we're doing those steps. We're doing a 4 times s step, and we're doing a 4 times 2 step. So that's where we get our 4s plus 8. Okay? Make sure you can do that. Make sure you've got your head around that distribution step. And go back and check your work. Make sure you all have all the steps written in there as well. Last one here, example 2. Kia's making a square quilt for her grandmother. It's going to have a 4 centimeter wide border around it. So all the way around, we've got this 4 centimeters. And at the top too, 4 centimeters. Now, it says she wants the perimeter of the completed quilt to be 600 centimeters. So maybe that's the exact amount of this stuff she's got. I don't know. But all the sides together, she wants to be 600 centimeters. But now it says how can Kia decide how long each side of the quilt should be before she adds the border? And that's the thing here, right? We definitely don't know how long this edge is. We also don't know this piece. We don't know this inside dimension. So we've got 2 unknowns here. What we do know is the 4 in the middle. So first, this is kind of a complicated question we've been given. So the suggestion here, I put a star beside it, is we start with a diagram that contains the necessary information to write an equation. So here's the other thing we can figure out. If we put an s in here as the inside dimension, then we see that the inside perimeter is 4 s's. And if we use that 4, well, this is an s in here, and we're adding 4 to the s here, and we're adding 4 to the s here. So this whole side is actually s plus 8. Now we can think about our perimeter as a function of that. We've got an s plus 8 along the top, we've got an s plus 8 along this side, and we've got an s plus 8 along the bottom, right? So we use that 4 that we knew, and we got ourselves to another way to represent the perimeter. That's going to help us out because now we know that the perimeter is just adding up all those sides, so it's 4 groups of that s plus 8 bit. And that's how we get to 600 centimeters, because the question told us she wants the completed perimeter to be 600 centimeters. So 2 ways now to solve that, and you saw these briefly the other day. The first is to divide first. So if we've got 4s plus 8 equals 600 centimeters, then we can divide that 4. We can figure out each side length. So each s plus 8 piece must be 600 divided by 4, so must be 150 centimeters. Now we can just take away the 8, and we get 142 centimeters. So S is equal to 142 centimeters. You could put that back into your diagram to just kind of rethink it. This is 142, this is 142, this is 142, this is 142. So yeah, all the way around when we do the S plus 8, we get our 150s back. And now 150 plus 150 is 300, plus 150 is 450, plus 150 is 600. The whole perimeter is the 600 centimeters. So that was our first method, was to divide first. Just shift a little bit so I can highlight. We divided first right here, right? And then we took away that 8. That was our second step. Took away the 8 from both sides to get to 142. Our second method is going to be to distribute first. And again, you saw these both the other day. So if you think you know it, you can go ahead and check your work and make sure you've got it. But do work it through. So we've got 4 sides, plus we've got 4 times 8, 32 centimeters of length. That's equal to our 600 centimeters. So now we can take away that 32 centimeters of length and take it away over here. So 5, 10, 9, 10. We got 568 centimeters if you want to see the subtraction step there. So 4s is equal to 568 centimeters. And now we can just divide by the 4. Because we took away the 32 centimeters, make up the border. We're going to divide by 4, and now we've got the s by itself is equal to, again, that 142 centimeters. So our steps there where we distributed, this is the distribution happening. We've got 4s plus 32. Then we subtracted our 32 from both sides. Then we divided by 4 here on both sides. And we got our s is equal to 142. Alright, it's up to you which one you use question to question, but you need to be familiar with both, and you definitely need to be familiar with what distribution means and how to do it. Thanks, guys. Again, make sure you've checked that. Make sure you've got all of those steps written in so you're seeing what's happening, so you're understanding what's happening. Don't let there be any surprises with any numbers showing up. Once you feel clear about it, go ahead and move on to the assignment and do the practice.